Assalamualaikum warahmatullahi wabarakatuh. Hi guys. So for this week, we are going to do experiment 9, which is about the password modulation or PCM. Okay, so password modulation is actually one method to convert the signal from analog to the digital. So this password modulation is used for digital transmission. Okay, previously we have covered the amplitude modulation and also frequency modulation. So both AM and FM are used for analog signal transmission. Okay, so for this one here, PCM are used for digital transmission. Okay, it is actually one of the methods to convert from the analog signal to the digital signal. Okay, before we go through about the PCM, let's take a look on the digital transmission first. What is digital transmission? So digital transmission is the transmission of digital signals between two or more points in a communication system. Okay, which means the input signal must be in digital form. Okay, and then if it is in an analog signal, so it has to be converted first from analog to the digital. Okay, the signal can be binary or any other form of discrete level digital pulses. Okay, the original sources may be in digital form, or it could be analog signals that have to be converted to digital pulses before the transmission and converted back to analog signals in the receiver. Okay, so for this digital transmission, it is required to have a physical facility, which means it cannot be propagated through wireless system. Okay, it must have a medium, for example, a coaxial cable, a wires, optical fiber, and so on. Okay, so now we go through about the pulse modulation first. Okay, so what is pulse modulation? Pulse modulation is methods of converting information into discrete pulse formed for transferring pulses from a source to destination over a physical transmission medium. Okay, methods of converting. So which means we have to convert any analog signal, okay, into digital signal by using this pulse modulation. There are actually 4 methods for pulse modulation. Okay, for example, here we have pulse position modulation, which is PPM, pulse width modulation, PWM, pulse amplitude modulation, PAM. Okay, and then what we are going to use is this one here, which is pulse code modulation. Okay, so pulse code modulation commonly used for digital transmission. Okay, and then it is a binary system which represent the pulse will represent the logic 0 and logic 1. Okay, this is what we are going to cover in this experiment 9. Okay, what are the advantages of digital transmission as compared to the analog? Okay, there are a few advantages. For example, by using digital transmission, the signal is immune to the noise. Okay, so it is less susceptible to the interference, okay, caused by the noise, and also it can be transmitted further as compared to the analog signal. Okay, so there are other advantages. You can also search for the advantages of the digital transmission as compared to analog. Okay, so we go through example of these 4 methods of the pulse modulation. You can see here from this diagram here, this is analog signal or information signal. Okay, so the information signal is in analog form. So what we are going to do is that we want to convert this analog signal into digital signal. Okay, so these are the methods that can be used to convert the analog signal to the digital signal. Okay, this is sample pulse. Okay, sample pulse means that this analog signal will be sampled in a specific time. Okay, for example, at T1 here, so it will be sample here, T2, it will take a sample here, T3, and so on. Okay, it will be the signal here will be sampled in a specific time. Okay, so for pulse width modulation, you can see here, when the signal is at the maximum amplitude, okay, the width will be at will have a wider width. Okay, so when it is at the minimum amplitude, so the width will become narrower. So this is how pulse width modulation is occurred. And pulse position, for the higher amplitude, the position of the pulse will be shifted to the right, and for the lower amplitude, it is shifted to the left. Okay, and then pulse amplitude, it is just different shape between the amplitude of the signal. Okay, so when the amplitude is higher, so it will have high amplitude, and when the amplitude of the analog signal is lower, so it has lower amplitude. Okay, this is what we are going to do, which is pulse code modulation, which means for each of the pulse here, okay, well, for example, this maximum here, it has a specific code, okay, which is in binary signal. Okay, for this one here, it will be 11111 and 0001. So it has a specific code here. Okay, for example here, it has also a specific numbers here, 0, 1, 0, 1, 1, 0. So it only has 0 and 1. Okay, so now we go to the PCM block diagram. So this is the block diagram for the transmitter and also the receiver. Okay, so you can see here, the input here will be in analog form. Okay, and then we want to convert this analog signal into digital signal here. And then after it is transmitted, and then we will convert it back from the digital signal back to the analog signal. So here are the process that occur in the PCM transmitter, and this one is occurred inside the PCM receiver. Okay, what occur in the PCM transmitter is that it go through this bandpass filter. So bandpass filter is to limit the frequency. Okay, so normally the frequency range is around 300 Hz to 3 kHz. Okay, and then it will go to the sample and hold circuit here. So this will periodically samples the analog input signal, and then it convert those samples to a multi-level PAM signal here. And then it will go through the analog to digital converter, okay, which converts the PAM samples here. Okay, we convert the PAM samples to the parallel PCM codes. Okay, and then this block here, the parallel to serial converter, will convert parallel PCM code to serial binary data, and then it will be transmit to the receiver. Okay, it will be transmitted to the receiver. Once it receives to the receiver here, the serial PCM code will be converted back to the parallel PCM code here. Okay, and then will then go through the digital to analog converter. It converts the parallel PCM to the multi-level PAM signal, and then whole circuit here is basically a low pass filter that converts the PAM signal to its original analog form.